Hi guys. Can you guys hear me? I can never tell with these things whether you guys can hear me. You guys can hear me? Okay, good, good. Great. Thank you. Thank you for letting me know. So, lunch or are you still hungry or have you been roaming around in the booths? So, how many of you had lunch properly? All of you? All of you? Okay. We don't want any starving attendees, right? Okay. So, if you think about it, AI today is pervasive, right? You go to a website, there is something related to artificial intelligence that's tracking your behavior. If you if you go to villages in farmland, there is something or the other sending data back to some kind of an AI model that does something that inferences something and uses that to further increase production. If you go to a factory, again, there's some aspect of AI that impacts your life. Okay, so so the next session here is going to talk about the impact of that AI has on business. And to talk about it, my colleague Madhu Shekhar, Principal Tech Evangelist, AWS. Please welcome Madhu to the stage.
Thanks, Rahul. Thanks, Rahul. Quick check if my voice is up and running. If people can hear me, please raise your hand, show a thumbs up. Great. Okay. Did you all have a good lunch? Raise your hand. Yes. Okay. So we're going to do this thing on AI over the next 30 minutes. I have Ashish who's going to join me a little bit later on to talk about how he actually applies it in his business. Ashish is from Policy Bazaar and we go from there. Good to go? Good to go? I'm asking the support team in the back. Thank you. All right. So, I think some people in the audience, I see them who are in the digital transformation track earlier on in the morning today. How many of you saw me there? Yeah, I'm going to be on stage many more times, so you may start getting bored of me. But what happens today is as you start accumulating, when you start putting things together, when you start building larger and larger systems, start integrating with customers, when customers start sending you information, when you start putting things in the field, IoT, cameras, mobile phones. You saw the demo today, right? We can have cameras that record, you have video feeds that come in. When you start putting all of these technologies together, you have a tremendous amount of data that you can work with. All of this data that comes in is connected and wired, and this can be processed in real time. Right? When you can process them in real time, or when you want to process that capability forward, you have the ability to take advantage with the machine learning and deep learning to build AI. Let's first take what that is. What is machine learning? Machine learning is the science and the algorithms, right? That's sitting out there that you will use to build artificial intelligence. Right? Not to confuse between the two. Machine learning is a statistical science, deep learning is a neural net, and when you take this math and science that's out there, when you put it to real world things and bring them together, you see artificial intelligence. So the way we define that is that in artificial intelligence, you expect that the tasks done by these things that you deal with, which otherwise, it sort of deals like in normal human beings. So when you interact with it, you expect it to behave back to you in a very normal form. Right? You need not adapt yourself for that system. That system will progressively adapt to you. That is AI. Right? That's the important part of AI. And you have to think about it that way. When you start building progressively more interesting artificially intelligent things, these systems will adapt into the human context. Right? Now, when we look at who is building AI, I mean, these are customers, right? You have Dynatrace, who's outside, you have Slack, you have RNIB, GoAnimate, Mapillary, we have Policy Bazaar, who's going to talk to you later. All of these companies are progressively building massive amounts of AI and machine learning capabilities on the AWS platform today. What can you build? What kind of fundamental things that you can build, and where will you build it? What are the areas you will focus on? Three primary areas, right? The first is, can you build seamless experiences, autonomous machines, or scientific breakthroughs? We'll walk through each one of them, and these are the areas that you will focus on when you're building these capabilities. Seamless experiences. I mean, I'm not showing you again a video of the Go Store, Amazon Go Store, because I'm sure many of you have seen this about a zillion times. So what I'm going to do is I'm going to explain what happens in there. Seamless experiences is about bringing in capabilities that makes an immersion possible. When you walk into the Go Store, think about what happens there. It is a very natural store. It looks like any other normal store. You go in there, you do your shopping the way you would do it, and then you walk away. Right? You don't have to do something special in the interaction model in the store in terms of how you pick something or how you put something back, etc. That is very different. Right? You behave normally. The system adapts to your context. The classic use cases when you build today, when you start building today, would be chatbots and robot advisors. When you build sentiment detection and response systems, when you build fraud prevention systems, these are systems that you can progressively build that enables a continuous seamless experience into the nature of what needs to happen. Those are the classic examples that you would go and build today. So again, let's take the Go Store here. Machine learning understands in-store purchase patterns. It sort of understands what this person typically buys. You have sensor fusion that's out there that looks at things that you picked up from the shelf, you put back on the shelf, right? There are cameras and sensors working in tandem to make sure this happens. It detects exactly what you did. One of the interesting things you can do at the Go Store, I mean, I really recommend when you go to Seattle to try this, is that you can actually take an item off the shelf and give it to someone else. It will still work. Right? It sort of understands what happened to the trail of items, right, and how it actually connects to one another, right? And systems that see. Now, when you look at Go Store and you're saying, okay, Madhu, this is great. It's, Amazon does this. Can I do this? Yes, you can. And we're going to look at what are those technologies that are available. And many of the technologies that we use at the Go Store are actually available to you as APIs or are available to you as machines that you can actually take advantage of. Yes, you will have to system integrate them together. You have to build things around that. But it is possible for you to build those kinds of systems today using the technology that we offer. Capital One, a financial services company, one of the largest card issuers in the US, has the capability. They actually integrate into Alexa as an interaction system so that using natural voice, customers can ask questions to it about their bank balances, about their credit worthiness, about the various products and services that they offer, and the system actually comes back and responds to them as to what is their current status, how they can take advantage of existing service. It even makes recommendations of what is it that they would need to take advantage of going forward. Right? These kinds of capabilities are there. It can authenticate today. Right? You can use voice ID in Alexa to actually authenticate against that. You cannot do that in India, definitely not today, but these are capabilities that are available in the market today. Expedia also uses it in a very interesting manner. What Expedia does is this. They have a zillion amount of photographs, hundreds of thousands of photographs coming from customers that tells them these are the pictures of these hotels. How do you know which of these pictures you want to show on the website? Right? There are pictures that you want to show and there are pictures you don't want to show of a hotel. Things that which pictures when shown would be more interesting to the customer, which increases the sale value. Right? I mean, if you show a picture of a hotel in a particular way, sale will increase. If you show the picture differently, the sale may decrease. Because customers are attracted to what they see. Right? They use neural machine learning and actually using the crowdsourced images, they're able to optimize and identify what pictures should actually be shown on their website. Next, the second experiences that you can improve are on autonomous machines. This is the Amazon Prime Air drone. But you can build capabilities that have, again, using sensor fusion, the ability to navigate in air, the ability to detect objects in air. The beauty with these kinds of machine learning systems is you can take, using Amazon Greengrass ML inference, you can build a training model on the cloud, take that ML model, apply it into this hardware. That means when this drone is flying, it does not need to be constantly connected to the cloud. It can execute most of the ML inference right on the hardware itself. It can recognize objects from the hardware. It can recognize obstacles from the hardware. It doesn't need to connect to the cloud to do it. Yes, it will have a connection to the cloud, but it can continue to navigate and behave intelligently even when it is off the cloud. That's the advantage of this. So predictive maintenance, shop floor automation, autonomous vehicles. Remember, when you're building autonomous vehicles or shop floor automation, you do not have time for the latency of going to the cloud and coming back when you're building these kinds of systems. You need to have the infrastructure and plane in place so that when the operations occur at situ and that location, you want to be able to go out. And then, you need not have to go out, but the model gets inferenced locally. And we look at what kind of capabilities come there as well. This is autonomous driving. This is too simple who's built a category 4 vehicle on top of our platform. So so we look at that. So this is daytime driving, object detection. That too simple runs on top of our platform. The vehicle actually automatically detects, identifies pedestrians, slows down, moves forward appropriately, and then goes in. This is a the warehouse optimization that we do in AWS, in Amazon. We have gained 50% operational efficiencies by using robots to actually move warehousing shelves. These robots actually move the shelf so that the pickers don't have to move. Previously, pickers used to walk almost 10 kilometers a day picking things from shelves so that items come to you on time. With the robots now doing that, your deliveries are much more assured on time. We know exactly what needs to be shipped. We can order things, and if you carefully look at those shelves, the items in those shelves are not ordered. It's not the same item across the shelves. These are actually different items. Wherever there is space, what are the items that people buy together or group together are actually in the same shelf. So that the robots can optimize which shelf needs to be brought to the picker, as opposed to the other way that we think, which is keep all the items together so that the person can go there. Right? Optimization models are very different here. So again, using vision technologies, you have the ability to understand what is on the shelf, what space do you have, how do you look inside, and figure out, okay, I can take advantage of the space. 50% efficiencies in warehouse can be attained. Scientific breakthroughs, patient treatment and safety, urban maintenance, utility and grid efficiency. Very recently, yesterday actually, I don't have a slide on it, but yesterday Matt Wood actually tweeted about doing quantum disposition testing, like identifying quantum particles and their movement using Amazon SageMaker. Right, because it's a huge probabilistic theory, and how you can use SageMaker to actually identify that, right? Quantum and particle advancements, livestock health, cancer treatments, so on and so forth. Artyrus is a company that actually does sensitivity detection and identifies, it can visually show you your arteries and veins, separating them from tissue. Right? This is again vision technology that's being applied to bring that forward. Think about the kind of advancements you can do it. Now, these advancements don't have to be at the other end of the spectrum. You can apply it in very, very early stages. You can apply it for simple problems. You can apply it for extremely simple things that you want to do. Right? Illumina is using it for applied genomics. In 2000, sequencing costed about $1 billion. Today, it's about $1,000. You can move the whole infrastructure, and 100x savings in cost when you're doing genome sequencing today. Artificial intelligence requires a complete set of technologies, right? And the challenge there is not only do you need the technologies, but you also need to have people who understand the science, the construct, the math, the data. All of that needs to come in. So, for example, if you want to be able to detect people in the room, or you want to be able to detect objects in the room, one of the key challenges you have is you must have enough data to be able to train the system with it. If you want to build a machine translation system, you need to have enough text and language and data for you to be able to build one. Yes, there are public data sets available, but do we want to train everything ourselves? Do we want to build everything ourselves? Not necessarily, right? There are APIs and services that you can take advantage of. But when you build your business, you may also want to be careful about the fact that there is specific aspects of data that is only unique to your business that you will bring to the table. So when we look at and built our machine learning stack, what we did is we basically separated them as services, platforms, engines, and infrastructure. On top, we have our basic services. This is vision, speech, language, and chat. What these services allow is pre-packaged services that you have, through which you can extremely simply add basic features to your software. Let's think about what these features are. Traditionally, software can deal with data that comes to you and use data to be processed. But what happens when software has the capability to see? Software has the capability to talk. Software has the capability to listen. 3 simple things that you want to do, right? Those are services available to you as vision, speech, language, and chat, so that these APIs can be used by you to build these sophisticated interactions and capability, which elevates your software to another plane completely. Let's take a very simple example. You have a form, equivalent of a KYC form. Somebody fills out the form. Somewhere in there, you have to upload a picture, a passport size picture. Very straightforward, a very classical use case. The person you will validate the first name and last name of the person. You will validate the last name contains 2 characters. How many developers in the room here? Nice. Great. So most of you would have validated the last name has at least 2 characters. All of you would have validated that the date of birth is a date earlier than today and is actually a valid date. You would have validated the phone number has 10 digits and maybe even the first 3 or 4 digits of the phone number to say it matches the pattern. But when you ask for the picture, you will upload and validate whether the picture is a JPG or PNG, nothing more inside. I could have uploaded a picture of a dog and you wouldn't know. Am I right? But if your software can see, it can actually tell you it's a dog, it's not a passport size picture of you. There are ways to do that, right? So these vision services and speech services allow you to build this kind of sophistication and say, this is something that's acceptable, this is what I can do. For example, I take Shadi.com as an example. When you set up a profile in Shadi.com, Shadi actually uses Amazon recognition to validate that the picture that you're uploading is not that of a celebrity and it is actually you. I'm sure they want to do that, right? They also validate that the picture is actually moderation ready. What is moderation ready? That the picture is not something where the person has revealed themselves with improper clothing. Or that the picture that they are uploading is that is suitable for it to be done. It's not like, there are 2 people in the picture. It has to be 1 person in the picture. Not 2 or 3 people. It's not a group photograph that you're uploading, right? They have to do these validations. Previously, they used to do this manually. Now they don't have to. The software can actually see. They use our API to figure that out and they validate these pictures. Some pictures will miss out, then they have the manual validation go in. But if you can save even 10% of the workflow for 100,000 profiles being created a day, you have massive savings that come in and massive intelligence that you're able to bring to the process. So Amazon recognition is basically that capability. It has the ability for you to look at a picture, look at things that are in the picture. Let's say you put a face out there, you can actually look at the demographic data on the picture. Male, female, what is the age range, the facial landmarks, the emotional state, the general attributes of the picture in terms of size. For example, is the face 30% of the picture or 50% of the picture? You will have the width, height and the coordinates of the face. Through which you can figure out, okay, if the face is 30% of the picture, you know what, it's not necessarily a passport size picture. Right? If it's 65% of the picture, it is a passport photograph. You can make that. If there are more than 1 face in the photo, not a passport size photo. If there are other objects in the photo, not a passport size photo. If the person is wearing sunglasses, it is a passport photo. It's a nice portrait, but you know what? I don't want a sunglass of you in there. You can do that kind of detection. You can do object and scene detection for a number of other purposes. You can actually identify, like for example, in this scene, it will actually identify the fact there's a skateboard, sport, people, person, human being, parking, intersection, road, boardwalk. All of this is identified as part of the picture. And we've been improving this continuously. So for example, we have the ability to read text. Like for example, there it says, think like there is no box there, right? It can read that text and actually give you that response. It has crowd mode detection. So that's, for example, if I took a selfie, a picture right here, it will pick up to 100 faces in a single photograph, right? And you can actually have information on each one of them. Then we added recognition video. Recognition video goes 1 step further. It can do everything recognition image can do, which is object scene detection, facial analysis. It can actually detect your, the facial expressions, the emotional state and all that. But it can in addition do activity tracking. Think about a person who's walking through that door right now. When that person is in that corner, do you know whether they're entering the room or leaving the room? A photograph will not tell you that. Right? If you look at activity detection, you can actually detect that because the person came in or left out. It cuts across frames to detect what actually happened in the activity. If I'm standing here like this, it looks like I'm talking in a photograph. I may not have been. But if I've been talking, there is audio information to tell you that I'm actually talking. I'm actually presenting in a conference, right? That is auditory information. There is spatial, temporal, and auditory information from a video that is actually used to make a recognition video to tell you what's going on, what is the activity that is there. The second thing it can do is it can do object tracking. Right? Object tracking is the ability for you to track an object. As you can see in the bottom, when the person is walking, you can identify that person and keep track of that person as you go forward. That's Amazon recognition for you. Next is Amazon Poly. Poly is the capability through which you can make your software to talk. Poly is available in 24 languages across 50 voice tones. No Indian languages today, but Indian English is supported through 2 different voices, Ravina and Aditi. Right? You have the ability to create content. You have the ability to input a piece of text, 1 API call, 1 line of code. input a piece of text, the voice will get generated based on the voice and tone that you want. You have the ability to control the rate of the voice. You can using SSML. SSML is a W3C standard. Using that, you can have tags that say whether somebody needs to speak fast for a particular section of the text. The same way you will do bold, italics, underline, etc. in your HTML today, you can actually have the voice be moderated. You can increase the velocity of the voice, you can reduce the velocity of the voice, you can increase the pitch, you can decrease the pitch, you can make it whisper, you can make it breathe. Right? Remember, humans breathe when they talk. So you can make it breathe. You can have the voice tone changed a little bit so that it sounds a little different. All of these capabilities are available via SSML. If you do not like a particular pronunciation of Polly in a particular way that it speaks, you also have the ability to change the way it pronounces. For example, my name is Madhu, right? When I give the name Madhu as my spelling going in, it might actually end up pronouncing it as Madhu, right? Which is fairly normal for a number of cases. But if I wanted to say Madhu correctly, I have a way of putting that in the phoneme construct inside the configuration of Polly, and once I do that, it has a way of changing the pronunciation to spell that out. And this is a library that you build for yourself, which improves the constant nature of how Polly functions for you. Right? It also has a much more interesting thing. You can actually, for example, the temperature in SGP is 33. If that is the string you provide, it will actually spell it out and say the temperature in Singapore is 33 degrees Celsius. It knows SGP translates to Singapore, and what you put there as text is actually 33 degrees Celsius. It has a way to do that. GoAnimate has been using it to give voice for characters that they animate. GoAnimate actually builds animation characters. Development studio that does that. What they're doing is to give lifelike speech to those characters. They actually use Polly to drive that. Another interesting capability of Polly is the fact when you generate those voices, you also can generate speech marks. Speech marks is the mechanics. It gives you all the annotation capabilities that you can put back into your 3D software, and the 3D software will actually generate the lip movements. That's very normal in the animation industry. So you give the voice, it will generate the speech audio, and it will also generate the speech marks. Take the speech marks, put it back in your animation software, and the lip movements will actually synchronize with your audio. Then we go to language services. As part of language services, we have Amazon Transcribe. Amazon Transcribe it fundamentally has the ability to add listening capabilities to your software. What is listening? You give a piece of audio, your software can listen and convert that to text. Right? It supports both 16 kilohertz and 8 kilohertz. It can differentiate between multiple speakers and it can do punctuation and formatting. A simple example of punctuation and formatting would be if I say my email ID is mdsudan@hotmail.com, it would not render that as my email ID is mdsudan@hotmail.com. That would be incorrect. You won't actually have the email ID pop up in the text when it is written. Transcribe will actually do that. It will do that for URLs, it will do that for email IDs, it will do that. It will add commas, it will add exclamation marks, it will add question marks for interrogation, and it will paragraph as you pause. When voices break through, it will actually paragraph that as well. It will tell you who speaker 1 is, who speaker 2 is. It will additionally ensure that when it is doing that for audio, you can actually also generate timestamps, which means you can generate subtitling for your movies, for your audio scripts. Out of existing audio recording, when you generate your transcription, it will actually give you the timestamps of the audio, which means you know how the actually audio flowed in that. You can actually add the most important thing, you can actually add additional pronunciation into transcribe so that you can make it generate your own keywords and things like that. Amazon Comprehend is another language service. It is NLP based. What it does is given a sentence, it can understand what is in there. It will break down that sentence. I don't know if you have another slide on it. Yeah, here is an example. So Mike compliments on the very rapid road opening in New York following Hurricane Sandy. If that's the sentence that actually came in, it will actually understand that there is a positive sentiment. It is in language English. It will understand the location city, New York. It will come out and tell you that Hurricane Sandy is entity. Right? This will come to you as a JSON response when you give this English text. Right? That these are the items it found and this is what it means from the text. And this could be small, simple sentences, which means you can take your Twitter feeds, your Facebook posts, etc., and route it to Comprehend to understand the sentiment, to understand what they are talking about. Like, for example, it can detect, okay, this person is having a positive sentiment about this product. right, or is having a positive sentiment about your company, right? You have the ability to do that. You also have the ability to understand whether it's a negative sentiment or not, and you also have the ability to understand about which are they having a negative sentiment and why are they having a negative sentiment. That's exactly what Amazon Comprehend can do. It can also do topic analysis. Topic analysis is the ability to send you a batch load of documents so that it will classify those documents into various groups. Another language service. Here, for example, you can classify email. You can classify a whole set of documents that you have in your enterprise so that you understand the subjects these documents are related to, if they are all sitting in your folder. That's another feature that Comprehend offers you to do. And then we have translate. Translate is the ability to go from one language to another. At this point, you can go from English to any of these other languages and backwards. So, for example, you can go from English to French and French to back to English, right? Back and forth. Again, one-line API calls. Remember, everything that I talked about so far is one line of code. One line to initialize the service, one line to make the call. There is no second line. Right? I normally would have done a demo, but today I've heard the network is having a challenge. Most of you probably are facing with your mobile phones as well. So I'm not able to do a demo, but I'll actually be walking through that code, and what you will see is most of that code is actually one line. Right? And what you will see is you can actually make these calls. You can send in a piece of text, it will translate and come back and tell you what those functions are. So here is an example. Amazon Web Services is a collection of cloud computing services. The important thing to understand is that when it translates this to Spanish, it did not convert Amazon as Amazonas. It figured Amazon is actually a company here, and it actually retained Amazon as it is. Amazon Web Services got retained as it is. It did not get translated. Whereas cloud computing services had to be reordered to meet the construct of how it would be spelled out in Spanish. Right? Because every language has its own, it's not word by word translation. You will have to restructure it to actually achieve the right kind of translation, the right kind of meaning. It also understands a lot of colloquialism. For example, another example I'll give you is if I said, "Hi, how are you?" or "Hi, what's up?" Right? In French, when I translate, the "hi" will become "salut." If I said "hello," it will say "bonjour." Right? It'll actually put the right context. But let's say, for example, in English, I say "what's up." How many of you know what WhatsApp is? WhatsApp is basically what's going on. Correct? It's not "what's up." When you translate it in French, you can't say "what's up." Right? There is no WhatsApp equivalent in French. So it'll actually convert it to "what's new" going into French. Right? That's understanding the context and trying to get to the nearest possible translation that makes the most sense. That's something Translate will do for you. And Lex is, of course, our chatbot building capability. You can build chatbots, appointment booking. These are intent-driven conversations. What you focus on here is the ability where, this is Lex. Lex is the underlying engine behind Alexa. What you see there, so it's intent-driven conversations where you basically say, I want to book a hotel, I want to book an appointment, I want to build, I want to understand what's going on with my product, why is it not working. You have the ability to go through a set sequence of interactions where it will ask you what to do. For example, here I want to book a hotel. The next thing the interaction will say, can you tell me which city, when would you like to go? Because these are pieces of information that's required to do it. But for example, if you ask the question, can you book me a hotel in Mumbai on the 23rd? It's one single ask. It'll understand all of that. Right? The next question would be, I found a hotel for you in New York on 23rd at place A, place B, and place C. Which one would you like me to confirm? Whereas if you said, I just want to book a hotel, it'll ask you, when would you like to go? How many nights? Then next question would be, where would you like to go? Great. Then I found this. That's intent-driven conversation, right? You can build these very straightforward, very simple. You have the ability to automate Lex as well. So Lex out of the box is integrated with Facebook Messenger, Slack, Kik, Amazon Connect. The best thing is it has an API. That means if you have a callback engine anywhere with any chat engine, if you have a callback capability, you can hook into that. Right? So mobile, web, devices, Amazon Connect, Facebook Messenger, Slack, ready to go. Of course, Lex can also read into Microsoft Dynamics, QuickBooks, Zendesk, Salesforce, and Marketer out of the box today. Adapters are available. Freshdesk is actually building their very own support help desk entirely out of Lex. Apart from the traditional support that they offer, they've extended that to now use ASR and NLU within Lex to drive support conversations forward. platforms. I'm not going to deep dive into this, but essentially this is the middleware. I mean, if you're not able to use these services to drive and you want to use your own data and your own construct to build your own specialized services, then you would use Amazon SageMaker and build an end-to-end capability. Amazon SageMaker is our machine learning platform. It offers you the control to build your own machine learning models, both statistical, neural nets, TensorFlow, MXNet. We love everything that is available in that space, right? I'm not going to skip through that. And then you have, beyond SageMaker, we have our capability that looks into deep learning. So you can use MXNet, TensorFlow, Cafe on our machine interfaces, on our hardware, including our P3 infrastructure. Including our P3 infrastructure to drive that. All of these customers, Clarify, Edmunds, Netflix, today builds extremely sophisticated machine learning products on top of this. To help you understand, some of the largest TensorFlows in the world run on AWS today, right? Largely because at the end of the day, you need massive amounts of compute. Gluon is a joint project between Microsoft and AWS, and what we're doing here is making it easy for you to develop on top of the traditional MXNet model, giving you a capability to, as an interface, to develop things very, very rapidly, right? You can experiment and prototype much more rapidly here. And of course, we have GPUs, CPUs, IoT, and mobile. Model training, you can inference. And this is the example I told you, that when you actually put machine learning on a drone or an autonomous vehicle, one of the key things that you want to ensure is the ability for you to train the model on the cloud and actually deploy it on these inference machines. And for that, we have Greengrass ML inference that's ready to go. Net off, you have Tesla V100 with 120 teraflops that's available. So if you launch a P3 24x large machine, you get 1 petaflop of compute for $25 a day today. 1 petaflop is a massive amount of compute. It's about 5,300 tensor processing units equivalent, right? On Amazon EC2, jointly with NVIDIA and Intel. We also have AWS Greengrass, which is running ML inference and capability on the local edge on your devices. Any Linux box with 128 MB of RAM, you can run Greengrass ML inference. That's the capability. Of course, if your local machine also has GPU capability, you can take advantage of it out of Greengrass today. And IoT. Fully integrated AI services ready for you to go. The question is, what is the art of possible? And to explore that further, I have Ashish.